Hello everyone, this is my camera train prototype. As you can see, it looks kind of like a Lionel TV car, and the camera will turn, as you notice, back and forth, and then the camera can tilt up and down. You can see it tilting up and down, and the light bar can rotate back and forth. We can turn the light bar on to full intensity. We can turn the intensity down to lower values. The light bar is really cool at night. So here we have it against the wall. You can see it's pretty bright there against the wall. Darken the lights, and it's really intense at night. Now let's get on the computer in Chrome and see how we can control it and record videos. So this is the screen from the camera car. You can turn the camera left and right as you're going down the track. You can tilt the camera up and down. You can see the ceiling here, and then you can see the ground. When I turn the lights on, you can see there's a spotlight, and if I rotate the light bar, you can see that the spotlight would move back and forth. You can focus on this car, for example. If we wanted to zoom into that car, right now we zoom out. If we wanted to zoom in, we could get closer view of that car. We can also focus on things. So basically, if I rotate this here and I want to focus on the train, I'm going to turn the camera down. You see my train car here. I can adjust the focus. I can start bringing things into focus. If you notice that once this is in focus, everything else is out of focus. So what's cool about that is you can highlight a certain thing and just kind of blend the light. At this point, we can start a recording. So it's recording this as we speak. I can zoom out the focus. Get the car in there. I can zoom into the car, tilt it up a little bit. Can go back and forth. Can get my spotlight over there to the boxcar better. And I can rotate over to the rocket car. Oops, went too far. So just imagine that you're like able to adjust the camera as you're driving down the track. So we're going to stop the recording, and then we notice that the recordings are here. So when you do that, the recording will actually play. So you see my recordings playing, everything that we did. At this point, you can save this if you want to your computer. You'd say download current recording. It's now recorded to your downloads folder. The rest of this video will be about how I designed this car and how I'm designing new boards for the actual production units. So here is my camera car, the completed design. I have some refinements to do in the future. I'm probably going to make these deck pieces a more detailed, but essentially we have the spinning camera turret with the tilting front, and then in here we have the Raspberry Pi 2W, very small Raspberry Pi, and then the seats for the characters to sit on, and the rotating light turret. I have 9 lights in this. The center 3 are not active, but it gives you the homage to the Lionel TV car. So let's dive into what's inside here. So if we hide this part here, you can see the Raspberry Pi single board computer in here. And then underneath is my board that provides the power, all the audio circuitry, and then eventually it's going to have the servo motor in it right now. This board is a first generation, and the problem with the first generation boards, a Raspberry Pi doesn't drive servo motors very well. It just does not have the timing functions it needs. So later on I'll kind of show some of the circuits that I've created in the new board. Go ahead and hide the bottom here, we will see what makes it all work. So basically, we have our turret mechanism that has a servo motor that rotates the camera, and there's another servo motor inside here. We'll look at that later. You can see my board design here would have all the access to the wiring. We have a servo motor here to rotate the turret. And then here we have a stepper motor driver board. This board is going away with the new board design. This had to be added later. Well, it's not stepper motor, but it's servo motor driver board. And the reason is that the Raspberry Pi just does not have good enough timing to do servos well. They jitter, which is not good. And as a result, I also put in here my power injection board to provide power to that servo board separately from the Raspberry Pi. And the reason I did that is that I have a supercapacitor on this power supply here, and it comes up slowly. That's okay for the Raspberry Pi because it has voltage detection circuitry and it won't start the Raspberry Pi until it powers good. But the servo motor board just doesn't like being powered up slowly, so I give it power supply through this. Now I want to get rid of this because that's a redundant part, so I'm going to redesign this board, and I'll show you that later in this video. If you want to see more about the camera module, we could show you that next. So in the camera module, I have various parts in here for the rotation. The servo motor rotates. This is top assembly. This is actually bolted to the bottom. The servo motor nestled in here. This wall kind of protects the flex cable for the camera. We have the little display panels here and the ladders, which are applied separately. And here's a servo motor inside that tilts this mechanism. I don't really care for this square bezel, so I think I'm going to turn it around so it looks more like a camera. The Raspberry Pi 3 Module 3 board. This module is actually upside down, so in software you can change it and you can flip it. So that's what I've done. So then we have the other assembly here. We have the light bar, and it's gear driven. I have this rotate, and only 3 wires come up into this assembly. It's controlled by my light board that I've developed for the bandstand. You can see that right here. And this board can control 6 lights. So these top lights and the bottom lights are controlled. This is my current board, and it connects to the Raspberry Pi, provides connection points for a bunch of the I/O. We have switches, we have speaker connections, we have connections for the NeoPixels, which controls the light bar, as well as servo motors. Servo motors can't be controlled by Raspberry Pi very well at all because Raspberry Pi doesn't have good timers in it, so they jitter. So I'm going to have to create a new board design, and I'll show you that next. This is my new board schematic. And you can see that there aren't any servo motors connected to the Raspberry Pi anymore. Instead, I communicate to a second chip with I2C, and I'll show you that on the next page. Overview of basically what I've connected here. It's been very simplified from the previous design. Just have the 4 switches connections. I have the connections for the audio, and then I have the connection for the NeoPixel. The NeoPixel can only go to pin 19 because the SPI MOSI is the only pin that has great timing, which is required for NeoPixels. The one addition that I did to this board that the previous board didn't have regarding to the motors is this PCA 9685 chip, which now I have the 8 motors connected to that. I have the I2C connections in here, as well as I've locked the address down to 0. And the next thing that I did is I added my switching circuit to turn on power when power is good off of the MPM 3620. This is required for supercaps. It doesn't really matter for Raspberry Pi single board computers because they already have a power management system on them, and they basically turn off if the voltage isn't good. But the servo motors will lock up if you don't do that. Now that my servos are powered by my power supply, I want to make sure they turn on only when the power is good. And once we've done all the schematic design, we go into the PC board layout. And I have a finished product here. You can see there's it's a 2-layer board. There's stuff on the front, as you can see here, and there's stuff on the back. And these little dots that you see here, these are called vias. They connect the front to the back. So what's neat about this is you can find, basically circuit board design is kind of CAD. You route these traces to the various things. And so the way you do it is you do a via and you pop through the board, for example in this one, and it goes to that pad. Because my new board basically has the same connections I showed that the previous board had. In addition, I added 3-volt pins, so when I use the switches, if I want to use Hall effect transistor type switches, I can power them using the 3 volts here. So that's kind of cool. And then I have basically still the same amount of servo motors, but now these servo motors are controlled by this chip here, which is the servo motor control chip. I still have the 2 audio amplifiers. Here I have my new super cap switching circuit, which is additional to this board. So to make this board, I had to move all this stuff to the left. There's still plenty of room on this board, but it has pretty much everything I need. Okay, so we're going to go ahead and order a board. Customs is still pretty high. Don't know if I want to order too many of these, but so I'm going to go ahead and order a smaller quantity, just because last time I did it was $600 for this order, because 200 of it was customs, and that's a lot. I'm going to go ahead and get less boards this time around just to make sure that they work, and because of customs I don't really want to outlay too much cash. And so we're going to put things on the top side. Now we want to confirm parts placement. And we're going to go ahead to the next step, where it'll allow you to select your files. We're going to add our bill of materials, and then we're going to add our placement file. Go ahead, it's going to come up with a list of parts, and we have to choose standard assembly for this particular part. It's going to go ahead and processing all the parts. It's going to say that it's not in the right spot, which it never is for some reason. And we have these tools in here. So what we're going to start with is we're going to start with the header for the Raspberry Pi. We're just going to go ahead and rotate that, and then we're going to place it approximately where it needs to go. This is a hand soldered part anyway, so they're going to just put it in themselves. So the place is not too important. This, on the other hand, though, the dot for the diode bridge is in the wrong spot, so we rotate that until it's in the right spot. The power supply is in the right spot, but rotated correctly, but it's in the wrong spot, so we move that QFN part down. And then you'll notice that the MOSFETs are okay. This servo driver chip is not in the right spot, so we'll move that, as well as the audio amplifiers are not in the right spots, so we rotate those too. And it looks like we should be done and ready to go to the next step. So we'll go ahead to the next step. It's going to estimate the prices for us. You're going to see that basically our assembly is $200. PC board is only $12. If I knew how to do this myself at home, that would be interesting if I had a pick and place machine, but I don't. They're going to load feeders. They got this fee for that. So it looks like they're going to use machine. Another cost that's interesting is because there's a QFN part and a ball array part for the amplifiers, they X-ray inspect it, which is kind of neat. You get a report. We're not going to expedite it. We're just going to leave it at 4 to 5 days. Now we have to choose our customs designation. So if we choose research and education and toy, That's what I use for trains, because trains is a toy. And we save this to the cart. Now you notice that the total price is $223. We're going to be charged a 60% duty on this, which is not so great, but it is what it is. So we're going to choose these all to be made. And we got my shipping address and shipping method. We're going to go ahead and do UPS Express Saver. It's cheaper. So once you place your order at JCL PCB, the engineers will go through it. They'll create the boards, and then you have to approve the board. So basically, here's the board. You can see that it has breakaway sections. The reason they do this is they have to put these tooling holes in order for them to go through their automated pick and place machines. And you notice that just like before, I have everything located. You can see that they have a pin 1 here, and all the parts are on correctly. You can see that the pin 1 designators are matching for all the parts. They had moved the power supply part to the right location. You can notice that the silk screen is kind of cut away here. They do that automatically. I probably should change the footprint so that that doesn't need to be done. You can see the audio amps are in the right spots. All the MOSFETs are in the right spots. The diode bridge is in the right spots. And they typically put a number on it to be identified. And so it's all good to go. So I'm going to go ahead and submit to proceed to production. Thank you for watching my video. Please like and subscribe and tell others about the channel.